Hello, everyone. I see a lot of people have already joined and some are still joining. There are people from Australia, from UK, and a bigger lot from Canada and USA who have joined us. I'm thrilled to see so many people joining from across the globe. Wow. So anyways, we are at 2 and hello, everyone. I'm Shubham, Senior Product Marketing Manager at ZTR and your host for today. Welcome to our webinar on key benefits of upgrading the locomotive control system. Now, since we are on time, I'll start with the agenda of the session while people continue joining in. We'll start with a short introduction of our organization and the speakers. We then discuss about conventional locomotive control systems and challenges with them. We further explore what to expect from an advanced control system. Following this, we dive into the features and benefits of our flagship control system, NEXSYS, to discover the advantages it delivers and also go through some case studies elaborating the benefits our customers have firsthand experienced. So NEXSYS has been evolving since its beginning. It's still evolving, and we're doing some great things with it. In this session, we also look at how it may look in future. And this will be followed by a question and answer session where we'll answer all the questions you may have about control systems, features, technology, ZTR, or NEXSYS. So please feel free to submit your questions throughout the presentation and as and when you have one, because we tend to forget in the end, like what was my question. So submit it as soon as you remember one or as soon as you have one. And you can do this by clicking the message box you see on your screen. So starting, so about us. So we are from ZTR. For those of us who don't know ZTR, we are 37-year-old rail technology company that has been providing technology solutions to the rail industry, including locomotive control systems and telematics. So we are industry leaders in locomotive modernizations, rail digitalization, and remote monitoring, and have been pioneers of a few technologies in the industry uh, like the AESS systems and the supercapacitor star technology. So we have a global footprint with more than 10,000 of our control products installed on railways across the world. And here are the experts, Amarjeet and Ruben. Between both of them, they have around 40 years of experience in the rail industry. Amarjeet Sura is our senior product manager. And at ZTR, Amarjeet is fondly called AM, the first two alphabets of his name. And AM's background is electrical engineering, and he has spent most of the last 28 years in various engineering roles in the rail industry. Having been with ZTR for now almost 25 years, AM now oversees the introduction and lifecycle of ZTR's control and monitoring solutions. AM has also held various positions in the LMOA, the Locomotive Maintenance Officers Association's Electrical Committee, and currently is the third VP in this association. And then we have Ruben Campus. He is one of our product development managers. He studied electrical engineering in London, Ontario, and has spent the last 11 years serving the rail industry. So, as an applications engineer, Ruben has worked with several major railroads across the world with the objective to help them get the most out of their investment into ZTR products, including Class 1 program management services. So today, Ruben draws inspiration from his past experiences to help shape the future of our products and our industry. So I'm pretty confident by the end of our session, you'll gain valuable insights into advanced locomotive control systems and the benefits that you can get by installing them on your locomotives. So before I pass on to Ruben, let's have a quiz. This is just to get us started. And the question is, what is the basic function of all locomotive control systems? You can see the quiz on your screen. And yep, you can vote to it. Well, this has been interesting, and Ruben and Am warned me earlier that this is a pretty easy quiz, and I should be I should make it more tough, but I thought no, it's okay. This would set the context. So these are the results. As you see, like 95% say regulate power output and addition of the locomotive controls of the locomotive is the primary function or the basic function of all control systems that should have. So this looks interesting and not exactly, but yeah, I'll invite Ruben to take over the discussion to discuss about locomotive control systems, challenges, and more. And please ask any questions you may have during the presentation. Ruben, the stage is yours.
Thank you. Thank you for the kind introduction, Shubham. I'm just waiting for the screen to refresh here on my side before I get going.
Can you see it now?
Not yet?
Okay. So there's some gap in there, and yep. I'll just stop and yep. Can you see it now?
Yes, I can see it now.
Yeah.
Okay,
Yeah.
let's get going. First and foremost, it's an honor and a pleasure to be here today presenting to you and to this industry some of the technology passions, some of my passions. Let us start this journey by describing a locomotive system, control system, as the brain of a locomotive. A control system is responsible for managing many functions, and it's also responsible for ensuring safety, efficiency, and performance. A mentor of mine a long time ago explained to me that a locomotive system is like a symphony. Yes, I'm talking about a musical symphony. A large group of instruments with distinct roles, taking turns to play their melodies, creating something beautiful and exciting. Ever so carefully working together to achieve motion. A locomotive control system is just that, is a complex group of hardware and software systems working together to regulate features such as speed, traction, and also monitoring critical parameters such as engine temperature or engine performance. I'm trying to change to the next slide here. There we go. Okay, so when I first started working with locomotive control systems, I was amazed and humbled really by the marvelous feat of electrical and mechanical engineering. Truly creative minds developed control systems, the control systems from last century. These systems were robust and they helped shape the rail industry we know today. However, our industry has moved forward. Over the decades, challenges and issues have emerged, each posing unique obstacles to the efficient operation of the rail transportation system. While the following list is not an exhaustive list whatsoever, at SETTR we have worked with railroads across the world, and the following 8 challenges are a common factor across the industry. Let's start with outdated technology. Many locomotives still rely on decade-old control system. Some are outdated, some others are obsolete. Outdated technology can impact performance, it can limit efficiency, and make it really difficult to implement new safety measures. Maintenance and reliability. Maintenance is a constant concern in the rail industry, and locomotive control systems are no exception to that. Aging components, frequent wear and tear, and the complexity of the systems can lead to increased downtime and maintenance costs. lack of integration and compatibility. In today's interconnected world, integration with other systems, such as cab electronics, compatibility is essential for operation. Lack of integration can lead to inefficiencies, data silos, and difficulties in sharing information across our platforms and our networks. Inefficiencies in fuel consumption and performance. Fuel consumption represents a significant operational cost for railroads, and inefficient systems can exacerbate this challenge. We will explore solutions to this challenge in a few slides. Okay, moving on, regulatory compliance. The railway industry operates within a framework of stringent regulations and standards. Locomotive control systems must adhere to these regulations, which often evolve over time and almost always for really good reasons. Limited data, analytics, and insights. In the past, I've described the locomotive like a power plant on wheels. And much like power plants, locomotives generate vast amount of data. Harnessing this data and turning the data into actionable insights can be a challenge. Speaking of data, limited remote monitoring diagnostics. Now, remote monitoring and diagnostics offer significant benefits in terms of proactive maintenance and reduction of troubleshooting times. Now, lack of value in diagnostics can lead to increased downtime and maintenance cost. And lastly, lack of predictive maintenance. Predictive maintenance relies on advanced analytics and real-time monitoring to anticipate equipment failures and schedule maintenance proactively. So with those challenges out of the way, what should we expect from an advanced locomotive control system? The next two slides showcase customer curated expectations, desires, or needs from the technologies on board these locomotives or their locomotives. Let's start with seamless integration and interoperability. An advanced locomotive control system should integrate with various onboard and offboard systems. This includes operating with signaling systems, air brake systems, communication networks, and other emerging technologies. They should also have enhanced performance and efficiency. Advanced control systems are expected to optimize locomotive performance and fuel efficiency. They should have superior reliability and maintenance. Reliability is paramount in railway operations, and an advanced control system should deliver superior reliability and uptime or availability. What's the key to availability? Well, the key is robust hardware and software components working together. Improved safety and compliance. Now, it's very well known that safety is the top priority in the rail industry. And an advanced control system should prioritize safety features and regulatory compliance. These safety measures help mitigate risks and protect crew and equipment. Real-time data analytics and insights. So advanced control systems should leverage real-time data analytic capabilities to provide actionable insights, turning data into information. And fleet managers benefit from evaluating information to make informed decisions, to improve their fleet, and to enhance their overall performance. There's also scalability and flexibility. An advanced control system should be scalable and adaptable to accommodate the evolving operational needs and the technological advancements. Whether expanding your fleet, integrating new technologies, or adapting to the changing regulatory requirements, the system should offer the flexibility and the scalability without significant redesign, or disruption to operations. Remote monitoring. Remote monitoring capabilities are now essential and almost a given, but they're essential for operations. They're essential for maintenance. They're essential for troubleshooting in a modern railway environment. Remote monitoring facilitates early detection of issues. They can help reduce downtime, and they enhance the overall operational efficiency. And lastly, cost-effective investment in really ROI, right? So the return on your investment. While investing in an advanced control system entails a lot of upfront cost, it should offer a compelling return on the investment over the locomotive's life cycle, and that's over decades. This includes savings in fuel consumptions, and also we're going to talk about operational efficiency gains. So these expectations, desires, or needs from an advanced control system can deliver value, significant value to railroads, and they can really enhance efficiencies, safety, sustainability, while providing a solid return on investment. What do we offer? Well, allow me to start to answer that question by presenting a brief history of us. As Shubhan mentioned at the beginning of the presentation, ZTR was forged from innovation. We disrupted the industry by introducing the first AESS system. By the 1990s, we introduced digital systems that exceeded performance of analog control systems. At the turn of the century, we focused on improving our diagnostic offerings and started connecting our products to what we now call, or what is commonly known as, the cloud. Over the next decade, our flagship product, NEXSYS 3i, introduced advanced control system theory to the industry. And as cellular networks developed, our products became always connected. As we entered our version of the Roaring 20s, ZTR transitioned into so much more than a control system company. We are a technology company. We are battery experts. We are energy experts. And ensuring that our supercapacitor products reduced and soon eliminate dead one starts is part of our ambitions and part of our technology, part of our DNA. Allow me to roll out the red carpet for the NEXSYS product family. Around 1995, we introduced NEXSYS 1. With over 200 control systems deployed and installed across the world, it introduced excitation control, as I mentioned, wheel slip protection, transition, and DC generator control. 2002 came along the NEXSYS 2. Around 500 of these were deployed across the world. It was a direct replacement to the Dash 2 control system. It introduced onboard diagnostic. It had features like ground reset, automated ground reset, and it had DB control. In around 2010 came NEXSYS 3i. Now, NEXSYS 3i is our flagship product, and we've deployed over 1,100 of these products across the world. Yes, it has optimized tractive effort. It has integrated AESS, our Smart Start product, battery management, full contactor control, full onboard and offboard diagnostics, and the list goes on and on and on and on. It is a flexible and scalable product. Now, this is the evolution of NEXSYS. But what is the advantage? Why NEXSYS? To talk about that, I will hand over the presentation over to my colleague, Sura, who will take us down the journey of the NEXSYS advantage.
Thank you, Ruben. And thank you for outlining the control system requirements and the challenges with them, and where we should be heading in a great level of detail. Thank you for that. Shubham, thank you for the kind introduction at the beginning. The audience here, just so they're aware, the initial introduction I saw yesterday in the dry run said something like Ruben has 11 years experience, Am has 111. So I'm grateful that you were able to tone that down. So thank you very much. Yeah, and welcome once again. I echo Ruben and Shubham in welcoming our global audience here, and we're thrilled to talk to you here today and to talk about control system upgrades and advantages. So Ruben just went through several features associated with control systems like NEXSYS. Rather than going through all of the features in detail, we'll just focus on several key areas where we provide strong benefits, and control systems should provide strong benefits with regards to today's market drivers. So we're talking specifically about efficiencies, operating expenses, and emissions. We'll also discuss the importance of information, data, and synthesis of the data and their positive impact on maintenance. So here's some examples. We'll focus on propulsion efficiency, reliability, emission and cost reduction, onboard diagnostics, drivers displays, remote monitoring, as Ruben mentioned, and the returns one can expect to see from a control system upgrade. So starting with propulsion efficiency. So here we're really talking about conventional diesel electric locomotives where the engine is turning a main generator or a traction alternator. And you may hear me use main generator and traction alternator interchangeably for the purposes of this discussion. The electrical output from that machine is then transferred to the traction motors in the trucks. The traction motors turn, they develop torque and power. They turn the wheels and the wheel touches the rail, and that's how propulsion and locomotive pushing and pulling essentially works. So it's all about optimizing that mechanical engine horsepower to the rail. And since the engine speed and traction alternator speed is governed by the crew when they set their throttle request, the means to control the optimization through the system is through the field excitation of that main generator. So by taking into account parameters such as motor characteristics, acceleration, just to name a couple, the system should adjust the main generator field excitation to ensure maximum horsepower, or call it tractive effort, adhesion, you can call that grip, or acceleration for train handling and motor limits. So it's all about taking these factors into account and ensuring good acceleration and optimal application of that horsepower to the rail. During dynamic braking, it works the other way, where the system is exciting the generator based on the driver request for braking effort and managing the application of the traction motor output to the dynamic brake grids and maintaining voltage and current so that the grids are well protected. And for yard operations, we can talk about pace setter control. So in yard operations where they need precision speed control for loading and unloading operations, control systems such as NEXSYS should offer integrated pace setter control where the driver essentially puts a target speed request in and the system takes care of the rest, almost like a cruise control for locomotives. So we talked about how it can happen. So here's some real world examples of NEXSYS in operation. So we're going to provide some documented test results showing the tractive effort gains, which is really more pulling power. So in this case, we had two SD40-2 locomotives, one with the OEM-2 controller, one with the NEXSYS 3i. They're exactly the same weight and equipment. These tests were conducted at TTCI, which is a subsidiary of the AAR, American Association of Railroads. A lot of words. What that means is it was tested independently by an independent body and documented for us. The tests were conducted on the same track, the same loads, and identical weather conditions. So this graph here is focusing on the low speed and showing the adhesion improvement under conditions of dry rail, no sand, so didn't have the aid of sanding for increasing adhesion. And you can see that low speeds below 10 to 12 miles per hour is where the advantage really starts to come in. So the -2 starting tractive effort is in the red, the NEXSYS is in the green, and then The blue is a theoretical maximum, so full power to the rail and no slippage happening. And you can see at about 2 miles per hour with NEXSYS, there's about a 44% increase in the tractive effort over the Dash 2. Oops, I'm too far. Okay, the next test. Same conditions, same place, same locomotives, same temperature conditions. Here the difference is that water hoses were applied to the lead axle of each locomotive, so simulating rainy or wet track conditions. And again, no sand, so you can call it, no sand, wet rail, call it worst case real world scenario, if you will. So again, red line is the Dash 2, green is the NEXSYS, blue is theoretical maximum. Obviously, it's harder to get to the maximum with the wet rail, but even then, there was a 30% increase in tractive effort and pulling power with NEXSYS over the OEM system that was on board there. So a lot of words, a lot of numbers. What does it all really mean? It really means that with this level of performance, you're going to get less stalled trains, which is less operational challenges. Being able to pull more with less, so potentially reducing the number of locomotives you need in certain operations, less damage to traction motors due to uncontrolled slip, and less wear on the wheel and rail sets, again, because we're controlling the slip that's happening. Reliability and availability. So we talked about performance gains, and now we're going to talk about some other aspects of improvements you should expect to see with a control system overhaul. So reliability is about, the locomotive not breaking down, parts not breaking down. And there's different metrics for this industry. There's mean time between failures, mean miles between failures. So they're all quantified differently, but really speaking about the same thing. And availability is about the amount of time or a percentage that the locomotive is available for service and, not shopped or under maintenance or anything like that. So we'll cover a few ways in this can be done, and they're listed there, and I'll get into some of the details. And the following slides, we'll cover that, and we'll also give some case studies quantifying some of these benefits as well. Bit of a delay here. For some reason it's not changing slides, Shabam.
You may try again, please.
Okay, perfect. There we go. Sorry about that. So rotating equipment protection. So this is some of the biggest elements and most costly elements of the locomotive that need to be protected in order to improve the reliability and availability of locomotives. So starting with the engine health monitoring. So here we're talking about monitoring some of the key operating parameters of the engine, oil, water, turbo, and these kind of things. And if parameters are at a certain level, alarming them and sending alerts, onboard alerts, and then more importantly, like Ruben mentioned, remote monitoring alerts so that people can take action and schedule maintenance before more costly damage will occur. Traction alternator, a main generator protection, and traction motor protection. So here we're talking about voltage protection to prevent flashovers, current regulation to prevent thermal damage to the motors, and then stall detection to prevent damage to the commutators and DC motors. So stall detection, we're talking about in DC motors being on a grade, locomotive is stalled, it's not moving, it's a heavy load, a lot of current going through the brushes and commutators which are not moving, and this results in permanent damage to the commutator bars. So dynamic brake grids. So I mentioned earlier about protecting your grids. So this is about voltage and current limits of your grids. And also there's always a fan, a grid blower fan that's operating to cool the grids during dynamic brake. It's important to know if they're working or if they're not working, and then to disable dynamic braking if they're not working to protect your grids. And it doesn't sound exciting, grids, but I'm going to state the obvious here. If you don't have grids, you don't have dynamic braking, and this could be an operational challenge as dispatch may be setting up their trains and locomotives depending on dynamic brake operation in some of the hilly terrain. Ground relay detection. So this is a twofold. It's about automatic reset of the ground relay to avoid some nuisance trips up to a certain limit. Then also monitoring the leakage current. So like looking for trends in leakage current. If you see it's trending the wrong way, you can schedule the locomotive for some level of, inspection, high potting or whatever have you. So these are ways that a control system such as NEXSYS will protect your rotating equipment and extend their life and reduce mainline failures. Okay, battery management. So batteries today serve many purposes on locomotives, much more than they did a long time ago when they were just used for starting locomotive. But at the risk of stating the obvious, if they're not in a good state of charge or good health, your locomotive won't start and you'll have an operational delay and service failures. So control systems should have battery charging to meet the manufacturer's guidelines for different battery types. So what we mean there is current limits to prevent gassing and overheating and gassing of sulfuric acid, which is a health hazard as well. So preventing the batteries from seeing higher currents than they should. Voltage limits to ensure adequate charging levels, whether it's in bulk, float, or absorption stage. So proper charging for your batteries extends their life and improves locomotive starting performance. Battery disconnect. So in the case of non-AESS shutdowns, which we'll talk about in a little bit, so locomotives manually shut down or is unexpectedly shut down, it's left unattended, and if you've got headlights and other loads on, the batteries will quickly drain, and when the crew comes to start the locomotive, battery's unable to turn that engine. So having some kind of automatic battery disconnect, which will disconnect those loads after a short amount of time and preserving the state of charge, is important for preserving engine starting reliability. And speaking of batteries, we also have this product Kickstart, and some of you may have attended a webinar that we had several months ago on it. This is a supercapacitor technology Ruben spoke of. If it's equipped on a locomotive and you have a control system like NEXSYS, it's important to have integration with a Kickstart so that you can also take advantage of some of the data and actionable insights that may be provided through the Kickstart, as well as starting performance and anything related to the battery. Fleet availability. So I touched on this briefly. And again, it's defined as a percentage of time the locomotive is available for service as a function of overall time. So if the locomotive is in service for 8 out of 10 days and it's in maintenance 2 out of 10 days, that's 80% availability, just as a simple math example. In one example that we have, major railroad with an aging fleet, a fairly large fleet, bumped their availability after they installed our control system from 91% to 94%. And 3% doesn't seem like such a big number, but when you take into the fleet size, the cost and financial impact of having locomotives out of service, they're not in revenue service, there's maintenance costs happening, maybe there's leasing costs, or you're spending leasing money and their locomotives aren't making you money. This is pretty substantial, and in this example, it amounted to about impacting $5.5 million a year for that fleet size, which is a significant number. And how was this achieved? So the reduction of problematic and in some cases obsolete components, so improving, reducing relays as an example, the battery load disconnect for the engine starting, equipment protection, better protection for your traction motor equipment and reducing equipment failures. And as Ruben pointed out earlier, remote monitoring to provide advanced information on maintenance that may be required. So say as an example, there is some kind of failure or deterioration of components. Before the locomotive gets to the shop, knowing what parts you need to have on order, having your technicians ready to service that locomotive when it comes in, reduces that overall downtime and increases the overall availability numbers, which is really important. So we previously touched upon traction motor protection and how control systems like NEXSYS can provide thermal and voltage protection and improving the reliability. So in this example here, we had a customer that had a fairly large fleet, and they experienced a very high traction motor failure rate. In their worst year, they had 1,000 traction motors that were failed and had to be replaced. And there's a number shown there about a traction motor replacement. That's the cost of the motor, taking the time to put the traction motor over the pit, or cranes, operations, what have you, to change out the traction motor. It's pretty expensive. So after the NEXSYS implementation through their fleet, they saw a 90% reduction in traction motor failures. And if you just do the math there shown on the bottom, this equated to, for their fleet size in a bad year, or flip side, in a good year, $18 million in savings. So again, a bit of a case study on the benefits of having good traction motor and rotating equipment protection in your control system. Let's go again. There we go. Emission reduction. So we've covered improving locomotive performance, availability, reliability. Now we'll talk about emissions. So some of you may have attended a webinar about our Smart Start product, which Ruben talked about earlier. And as a refresher, AESS systems have a pretty basic principle. Locomotive engine is idling. People don't want to shut it down because they're worried about starting reliability, the water temperature, freezing in temperate climates. So what an AESS will do is it'll look at some of these parameters and it'll shut the locomotive down automatically if the conditions are right. If the crew comes on to use the locomotive or any of the conditions trend in the negative direction, the system will initiate an auto restart, and it's usually associated with audible alerts, visual alerts for crew and maintenance safety. AESS systems are available as standalone upgrades, but it's advantageous to have it integrated with your control system, as troubleshooting and valuable fuel savings data are consolidated through one channel, whether that be onboard or through remote connectivity. And since AESS and control systems often monitor the same sets of parameters, having an integrated solution offers advantages in the form of reducing the number of redundant sensors that need to be installed and troubleshooting complexity and cost. Apologize why I keep having this delay as I'm transitioning. Okay, quiz time. So we're gonna do two things here. We're gonna test your knowledge of AESS, and we're gonna check how many people are still awake. Hopefully you're still all with us. So Shabam, I'll put it back to you.
Yep, I'm launching this quiz. I hope all of you can see this. Yes, most of us have voted. I close the poll now, and here are the results. 50% believe it would be something between 15,000 to 20,000, and while there's an equal distribution between 20,000 to 25,000 and 25,000 to 30,000. Why don't you take over and run us through a case study?
Sure, thank you.
Sorry, you may need to click again. Yeah.
Okay, great. So just some numbers to back up the performance of AESS systems. So here's some real world data that we've accumulated over time. So what you're really looking at is that the more the locomotive is in service, it stands to reason the more engine idle time it's going to have and the more opportunities for savings. So as shown in the previous slide, if you're up around that over 70% range, then your savings are going to be somewhere between $25,000 and $30,000 a year. And this is US dollars, by the way. And so this is just the dollars here based on fuel costs. And there's additional savings that can be realized in the form of tax credits for incentives or for reducing the carbon footprint as well. So that's not documented here. So the savings are actually probably more than this. Okay, before I hand it back to Ruben for remote diagnostics, I'll talk a little bit about onboard diagnostics. So the loss of skilled staff, relying on laptops and other tools, manuals and guides are examples of things that complicate troubleshooting. So it's important to have mechanisms to make troubleshooting as quick and simple as possible, and using an onboard HMI or human machine interface are efficient ways of doing this. So HMIs are widely available, but it's really about how you implement them and what you display. And here's some things important to making it successful. Being able to monitor locomotive parameters and functions in real time for active troubleshooting. Knowing the status of the system and the functions it's connected to. Automated tests, such as contactor and self-diagnostics, is important as well. Reports, ASS, duty cycle, and utilization, any kind of reports that need to be quickly accessed. Historical information, we're not always there when something happens on locomotive, so having access to historical information easily is very important for troubleshooting and fixing the problem quickly. Crew messages, and then, finally, a picture is 1,000 words. So having graphical information as much as possible, and gauges and graphs versus text and codes is probably the best way to go. And on the right there's some, I won't get into the details, but there's some screenshots of the graphical HMI that we have with every NEXSYS system. And rounding off with displays, we have our integrated locomotive display, the ILD. So this is the driver's display that can replace the mechanical gauges. So it alleviates several issues and offers advantages. So it'll eliminate those mechanical brake gauges, electrical load gauges, speedometer that require maintenance and calibration. And then Ruben earlier mentioned some of the challenges of conventional systems is lack of integration options. So with these kind of solutions, you can integrate with the modern cab electronics, and there's some examples of some of the subsystems shown on the right. And depending on local guidelines and codes, combined with the advanced microprocessor system like a NEXSYS, and having this kind of display may offer opportunities to extend periodic maintenance, periodic inspection intervals. So we talked about performance and features and functions, but they're only as good as the technology that backs it. So important to have select technology that offers very high reliability, rated to rail standards such as EN 50155 or the IEC 60571, to which NEXSYS is certified. Railroads expect technology to be available and lasting, not like this for 2 to 3 years, but for 10 to 15 to 20 years. So it's important to ensure that your technology can be available and supported for at least 10 years. And of course, it's always helpful to have a solid technical support team behind it as well. And I believe with that, I think I'm passing it back to you, Ruben.
Yes, thank you, Em. Let's see if I have control. Let's continue the NEXSYS Advantage journey, and let's talk
control now.
Remote monitoring. Sorry?
You have the control. Okay.
Awesome. Okay, so let's talk about remote monitoring, and I'm going to be mindful of time here. So what is remote monitoring? What do we offer? What do we have, right? So for NEXSYS, we do have a remote monitoring platform where users can have access, 24/7 access to near real-time data from NEXSYS equipped locomotives. Now, what does that mean? Through our portal, users can collect data for fleet health, fuel consumption, emissions, utilization, propulsion, and starting performance. Additionally, you can export data, trend locations, know where things are, where things have happened, and create an all-encompassing ecosystem of data and information. There are opportunities for API integration, or more explicitly, being able to offboard your data or the data from the control system over to your network. Part of our platform, I'm just trying to switch slides. So some of the features that our platform does provide are elements like geofencing, so being able to create a surface area or location where you can have custom alerts. And speaking of custom alerts, being able to have the ability to no one size fits all, and we understand and acknowledge that. So being able to cater to your needs is important. And as we move away from remote monitoring and we talk about the return on the investment, let's try to quantify some of the earlier mentioned advantages, including performance gains, idle reductions, and overall reliability and availability improvements. Diesel is getting more expensive, and long gone are the days of cheap fuel and 24/7 allowable idling periods. So our AESS system, Smart Start, has been shown to save around 330 gallons per month per locomotive. For our metric system friends, that's about 1,200 liters per month per locomotive. Smart low idle. Yes, the concept of low idling has been around for decades, and we know that in certain situations, this concept can reduce engine and fuel performance. However, by using a combination of sensors, we can be smart and ensure low idling only takes place under the right situation, thus ever so smartly contributing to your annual fuel savings. And lastly, improve tractive effort in the right situations, as Anne mentioned, pulling more with less. So we round all of this together. We're looking, and we have proven to have annual savings per locomotive of about $40,000 US. So that rounds off the NEXSYS advantage. And I thank you for your attention. I would like to hand the presentation back over to Em as it takes us into the future of NEXSYS.
Thank you, Ruben.
Thank you.
Okay, thanks, Ruben. Thanks, Shubham. Okay, so I'll try to get through this pretty quickly because I know we want to leave adequate a time for Q&A. So the future of NEXSYS. So Ruben outlined where we've been with NEXSYS, where we are, and some of the things we talk about, some of the features we have today. We're always adding and improving, keep up with current requirements, legislative requirements, operational requirements that our customers have. User feedback, improving the experience, whether it's the control system performance itself, the diagnostics, the remote data, and then keeping up with locomotive classes that are continually coming up for overhaul cycles. So making sure we're ready to help our customers there too. And some of the latest things we're looking at, some examples, new integrations. So there's technologies, we talk about the ILD and integrating with subsystems, but as examples, there's newer and more efficient engines on the market with electronic and fuel injection. So looking at integration options there as well. High horsepower. So we have experience with some, higher horsepower applications as well. We talk about Dash 2 a lot, but we've got SD60s, 3,000, 4,000 horsepower applications, Dash 8. So we're looking at expanding and getting those offerings to a broader market base. AC traction. So a lot of DC locomotives out there, but a lot of railroads looking to convert from DC to AC as well. So we're looking towards offering some level of integration and options to support that as well. Or if the locomotive has just got a 30-year-old AC traction system and they want to get rid of, GTOs or something like that, and they want to go to something more modern, looking to support that kind of path as well. And then something that you may have read some press releases about in the last year and a half that we're really excited about is our hybrid. So this is our development of a mother-daughter diesel battery hybrid locomotive set. So partnering with Union Pacific, great to work with. It's a really exciting relationship. This is currently in development and testing. And this is exciting not only from a technology perspective, right? Like a lot of engineers here, we find it cool. So the technology is exciting, but also it's in line with our history of offering solutions that help the environment and also help our railroads meet their admirable objectives when it comes to sustainability and reducing their carbon footprint, whether it's today or working towards 2050. So we really look forward to sharing more developments and exciting news with this as they occur. Thank you very much
Wow.
for your time and attention. Shabam, I'll hand it back to you to facilitate the Q&A.
Thank you, Am and Ruben. This was great, and we hope you all found that insightful. We already have a few questions asked during the webinar, and please feel free to ask any questions that you may have. We take them as we see them. So the first question that I have is, can your system work with remote control systems? Would you mind taking that? Can your system work with remote control systems?
Yes, we actually have, it's a good question. We have several applications with several railroads working with remote control locomotive systems, or commonly called RCLs, and with several different vendors as well. So the integration, we're they still have a remote control locomotive and the excitation system and wheel slip control and tractive effort and speed control, that it all works interchangeably. So the answer is yes.
And then the next question that we have is, do you use speed probes or radar for adhesion? Like, Ruben, do you mind taking that? Do you use speed probes or radar for adhesion?
No, that's a good question, and I can understand where it comes from. There are control systems that base their adhesion technology on with speed probe sensors. We do not. We focus our adhesion technology on other traction motor parameters. So for us is not so much the speed probes, is more on the power and electrical parameters such as voltage and current.
Okay.
If I can just add to Ruben's answer there as well, the vast majority of the components associated with the control system are installed in the high voltage cabinet. Very limited runs to other parts of the locomotive, maybe for some sensors for ambient or brake pressure, that kind of thing, but the vast majority are mounted in one location.
Okay. And then we have, does the age of the locomotive matter? So,
Well, given my 111 years of experience, I can say probably not. The control systems, and I can speak to NEXSYS as an example. It's been installed on locomotives, that were built as far back as probably the 1960s, all the way into the 1980s and maybe early 90s as well.
okay.
Yeah, I'll add a little bit on that, and just to sort of iterate some of the comments that Ann just mentioned there. I've had the pleasure of working with some schematics that are really, really old, and it's fun. It's fun to see something that's from the 1950s and the 1960s. So just to give you a flavor of, or sort of an insight of my personal experience going back 70, 80-year-old locomotives, and the success that has come from applying our control systems to those locomotives.
Okay.
Yeah, the fact that we're installing modern control systems on locomotives that old is a real testament to the engineering feats that happened when locomotives were developed, and the maintenance and upkeep from railroad staff as well.
Okay. And the next question is, what kind of diagnostics do you provide? Ruben?
Pardon me?
Ruben or Ram, like, what kind of diagnostics do you provide? That's a small question that we have, someone posted it. What kind of diagnostics do you provide? So we did speak about onboard diagnostics.
Sure, yeah, I'll field that one. Yeah, so diagnostics, there's a number of diagnostics that we have. So we talk about crew alerts, so crew member alerts to let them know if something is not operating effectively or correctly. We have diagnostic modes such as reduced operation mode, and the intent is that even when certain items do go down, we're able to continue to limp home mode almost, or still be able to continue to operate. In addition to that, we move on to commissioning screens that allow the user to test the system, auto contactor control, which allow the users to automatically verify wiring or the state of the contactors, automatic load test control, which is kind of a nifty feature that allows electricians, operators to automatically perform a load test, and out of all of that and all the different functions and diagnostic features, we then have alerts or events or faults that come with data, vast amount of data that allows us to then further troubleshoot or help and assist in the troubleshooting of whatever the problem had been. We can get down to the millisecond, second time frame where we can see what was happening at a time of an event and be able to provide that insight, so then we can turn that insight into actionable items.
And just to add to that, we talked a lot about the data, HMIs, and alerts. There's also provided with our system a number of visual alerts as well, like LEDs and lights for like if the AES is in operation, if the AES is initiating a startup, a shutdown, if the control system is derating traction motor current output because of thermal limits or that kind of thing. So everything Ruben said, plus some visual LED alerts as well.
Okay. And then we have a question like, I don't know if we have latest updates or not, but what new technology updates are going on with the locomotives governor? So, Ruben, what new technology or updates are going on with the locomotives governor?
Governor.
Yeah.
I think there, yeah. So the the locomotive governor, as some may know, right? It's the component that regulates fuel and power delivery from out of the engine. And historically, governors were mechanical. They were mechanically based. As that has shifted into an electronic control system, or electronic system, I should say, we can talk about electronic governors. We can talk about electronic fuel injectors and high pressure systems that that reduce the amount of fuel required to reach certain powers. I'm not sure, Evan, you have more to add to that?
No, I think that was about it. There's just been an evolution from mechanical to maintaining the same level of fuel injection, but just done electronically, metered through a electronic governor control, and then the progression to a different method of fuel injection as well.
Yeah, and I should note, I guess it is worth noting that NEXSYS as a product does have experience with working with electronic governors as well.
Yeah, and they offer some advantages too in terms of electrical integration. The more advanced that the electronic type governors are, the more diagnostic maintenance type information that can be fed back to NEXSYS and then put out through remote monitoring for maintenance actions as well. So it's good evolution and some good advantages, not only performance wise, but data wise.
Yeah, and then we have a question like, can you integrate with EFI? I believe electronic fuel injection. So there's this question. Would you want mind taking it? Can you integrate with the EFI? And
Yes, we have integrated with some EFIs in the past, and I may have mentioned on the part of the roadmap, there's lots of new vendors, lots of new EFI manufacturers, lots of new engine manufacturers, with tier 4 engines and those kind of options coming out. So we're looking at moving to those levels of integration as well.
we have several questions out pending. Do you offer on-site training for your systems? This is from Kim.
Yes.
Okay.
That's not only on-site training, but also on-site support for commissioning as well. There are, of course, the locomotive control system is ever complex, and being able to provide assistance to understand how our system operates and how to integrate it correctly is some of the services that we do provide, in addition to some of the application work that comes with installation instructions and schematics and commissioning instructions as well.
Okay, thank you everyone. We are out of time and there are pending questions. We'll reach out with answers to those questions. And if you have any further questions, please feel free to email us or call us or visit our website ztr.com. And you'll receive a feedback survey tomorrow. It will be great if you can provide your inputs. This will help us improve our future webinars. And yes, we are just on time. Once again, thank you everyone for joining us, and thank you, Pam and Ruben, for conducting this insightful webinar. Have a great day, and or maybe great night or great morning, everyone, wherever you are. Take care. Thank you.
Thank you.
Thank you.